Hello everyone and welcome into yet another live stream. Why is the stream already lagging? We haven't even gotten to the rendering bit of the stream. Why is it already lagging? Anyhow, let's play some music. There we go. So, hello everyone, and welcome into yet another live stream. Today we'll just be making a video once again. Just like last stream. Okay, so first I need to make a folder for the video. So give me a second. There. All right. And now we can just go straight for it. I'm sorry, why is OBS lagging? Hi there, Tilly Corbin. Hi there, on Pandy. There we go, initial example, and then just initial example, might as well. So, today we'll need to, well, actually set up the scene would be nice, and my taskbar is already broken. Something is going on in my Windows, it's just failing a lot. And the OBS is also not doing great. What's happening? Then I should be back. Hi there, hey guy. Welcome. What's happening? I mean, I'm just fighting with Windows again. Normal stuff. And making a video. So, initial example. Why does math break physics? In a simple way we break physics in math, we'll use a light bulb. This light bulb will turn on its photons and on towards light. Okay, so for this, we're gonna need a scene. As it just so happens in most of my animations. And in order to get the scene, we could actually use my favorite texture. Or at least the one I like using the most, because it looks really nice. So, texture is this one. I actually use it most of the time when I'm making stuff with a light bulb. Funny enough, and the reason why I like this texture so much is because if we take this light source, if we bring it down there, this looks garbage. This so far looks pretty garbage, but if we include reflections into an invert, like this, roughness, this already looks better. And then if we include normals, plug it in, then this looks worse. That's only because I have no idea how normals work. Is how normals work? Well, let's unplug them for now, just in case. And then if we take displacement and we plug it into displacement, and we plug the displacement in, then this already looks wrong. They've changed up some things. Or maybe displacement's not looking, maybe I'm just looking for bump. Okay, bump looks even. Ugh, okay, no. So the answer is no. World space. I think this is the one. Okay. So displacement into height. This one could be into scale, but it's way too much. So unplug this, and there. This already looks way better. How does he render so fast? When they always change this thing, it's so annoying. Can't remember 6 months ago. I mean, I like them changing stuff because they usually change for the better. So for example, what would be a good example of that? For example, with geometry nodes, they changed a lot of things, so you can't follow the early geometry nodes tutorials right now, but right now geometry nodes are much easier and better to use. Also, they did change the principal BSDF, I think 3 times, but each time they had a reason, and the most recent one, they added just a lot of different options. During the day, what wacky maths are we doing? We're making a video about wacky maths and physics and breaking physics. You can use wacky maths. That's what we're gonna be doing today. This is what we're going to be doing. And yeah, I feel like this texture looks decent enough, right? Do you have anything else we can use? Could use... Well, that's kind of it. I guess normals are still there, but I don't get how normals work. I've been using Blender for such a long time and I still don't... Yeah, because they make things asymmetrical, which... Or normal map, maybe? No, because normal... It shouldn't be asymmetrical. That's not how light works. That's not how light works. Light shouldn't be asymmetrical. Yeah, it's only when I do strength 0 when this actually looks normal. Pun intended, because it's normals. Yeah, this screwed up, this screwed up. I don't understand. It shouldn't... Yeah, no, we're not doing normals. What's the video being working on right now? Breaking physics using math, as I mentioned. Doing wacky math and using it to break physics. So, initial example. Why does math break physics? Oh yeah, we're not finished with the scene. In order to be finished with the scene, we not only need a floor, we need a full scene. Let's do it this way. Increase in size, well, yeah. But not increase in size with like mapping and then texture coordinates. So non-specific is I have to wait for the video and it comes out. No, I mean it's just the way I can describe it. It's just we'll be doing wacky maths and then wacky physics because of these wacky maths. Let's add bricks now. Bricks will need the exact same thing, except first let's unwrap. There we go, and then texture coordinate once again. This into mapping, and then mapping into bricks. And now all of a sudden they're all screwed up because we want UV, and then what we want is this 90? No. Not this 90. This 90? No. This 90. Yes. There we go. And now we'll need to actually modify it like this. There we go. Sweet. And now it's time for the rest. Like reflections, like bump into displacement, like this, and reflections into, and oh my lord, that's textured, alright? That is certainly textured. What happened to my dear and beloved displacement? I don't remember looking this way. I mean, this looks better, I suppose. Am I missing? I must be missing something. Or maybe this genuinely is how it's supposed to. Just decrease the scale. Oh, I think that is how it's supposed to be used, actually. That looks way better. Huh. Brick to my beloved. I mean, it's a really good looking brick, you know. Well, what wacky make it would look like. Maybe 2D make it in Looney Tunes art style, or 3D make it in Looney Tunes art style, you know. I can make it happen. Why does math break physics? That's the first thing I'm gonna have to ask, so let's do it. I really do want this to look nice, because there will be a lot of light work going on, and I feel like it would just fit. Why does math break physics? Did I do it right in the first try? I'm that good. I am just that good. And now we can have a mission of like 10. Because might as well. Ah, damn it. If I'm making it look nice, might as well go all in, right? Fine, I'll go all in. Might as well. And once again, the render time will be 50 hours. No. Okay. Why does my break physics? Let's do a 6. See how it looks. Why does my break physics? Yeah, okay. It looks fine. If the render time will be 80 hours again. If we're doing this, might as well also add depth of field. Okay, I'm curious. How long does one take to render and how does it look? Let's see. Why? Pretty. Yeah, it's actually not good enough frame wise. Finish example and frames. We can actually start with this one because if we delete the text, it's just gonna be a pitch black screen, so it doesn't really matter. Why does... Cool, one by one. Why does math? Yeah, why does math, am I right? Why does math? Oh, philosopher's mind, the empty dark space with a single word Y in the middle. Yeah, I can see it. Oh, look at those bricks. I know they're blurry and the background really dark, but they look good. They look good. I like them. Another sip of coffee? I would love to. Oh, that's good. Okay. It actually takes a lot less time to render than I thought it would, if I'm being honest. I really thought that this would take... Each frame would take minutes. But so far we're only on 32 seconds, which is pretty good. Could be worse, certainly. Now next, in the video, we will have... In this example, okay, the process input like let's use the light bulb. This light bulb. Moving to the normal image fonts, or no, was light. When the normal image fonts, no, it's light. Yeah, so all we need to do is just import light bulb, have it appear out of nowhere, I'm assuming. Currency, yeah, I would. I like money. I would somewhat even say I love money. Why does mine break? Yeah, when rendering word by word, these things tend to happen. This be funny. It's too hard. By the way, fun fact, every single time in any of my videos is if you see text appearing word by word with camera being static, that means I really went through the process. Just like I'm going right now. I just rendered it frame by frame manually. Because it's the quickest way to do it. Every single time you see a glowing text appear like word by word, when the camera is still, that really means I did it manually. You should make it letter by letter. No, I shouldn't. No, I mean, I could. Actually, if I were to do it letter by letter, I would just set up with geometry nodes, and it would take around the same amount of time. Basic idea, you can take the geometry nodes, the only reason why I don't do letter by letter is because it's not as well aligned. Pixel per pixel. I could also do pixel per pixel. Actually, both pixel per pixel and letter by letter is not that difficult. Okay, for letter by letter, you just take geometry nodes and you start with the string. So for example, A, then you convert that into a curve, then you fill in, or rather a curve, and then you fill in that curve. And then you extrude that curve. And then you just render it. And what's really nice is that in this case, in between these two, you can add a node which just cuts up the thing, so that you just input how many letters you'd like to have. So 1 letter or 2 letters or 3 letters, and then I can just render frames with them keyframed, so that each frame we just add 1 to this number. So first frame there's only 1 letter, second frame there's 2, third frame there's 3, and so on and so forth. So it's not actually that difficult. And for pixel by pixel it's also pretty easy, because when it goes to shading, you do... Oh yes, disconnected! What? Ask why'd you disconnect? That would be pretty swell if I could. I'm just wondering why you felt the need to disconnect. Anyhow, then for pixel by pixel is the same thing, except you have the X coordinate. So you just start... Actually, I've done pixel by pixel in different videos, where the text just appears left to right. Or right to left, or up to down, down to up, or front to back, back to front. Doesn't matter. The point is, light bulb. That's the point. Models and light bulb. That looks like me. Oh, that's interesting. The background is dark, maybe the light bulb existed before, but only lights up when you mention it. I could do that actually. That's not the worst idea, you know, hold on. Huh. The only problem is that the background is blurry. And I would like the light bulb to be... Huh. So I wanted the light bulb to be like this, maybe. Or even better, in front. That's a light bulb moment. Hi, the theft. Great idea. Yeah. I didn't even think of that. Because here's the thing, I get what you mean, Roxana, and that's a good idea of like light bulb being back here, and then it's hard to tell it's a light bulb because it's in the background, it's really dark as the words appear, and then when I say light bulb, it just lights up. I get the idea. The only problem is that I would need it to be in the middle. And all I need to do is... Okay, so this should be the inside. Which means this should be glass. Glass, which means that this should be just principal BSDF. Roughness down, metallic up, dark gray, and you... EQR to like 105 or 103. Here we go, and then the inside we have emission. And there, now we can control the brightness of our light bulb. Hi there, Akshat. Hi. I mean, that looks pretty good. Why does math break physics? Question for the ages, isn't it? That we're gonna answer in this video. Isn't that awesome? That we can just answer deep philosophical questions like this. Fly. Yeah, we're pretty amazing. Hi the cheese! Welcome. And why you are so small today? First of all, rude, okay. Mean. And why is there a keyframe too? Yeah, let's do 120 frames, I have an idea. We can have the light bulb pop a bit lower down. Actually, like, let's just say this. There we go. And then... like this, and then it drops, and then just screws itself in. Nope, not one continuous, only rebounds. Yeah, it looks pretty good. The wheel thing, he's above average. Precisely, I'm pretty tall. Like, there's no need to compare. I would say I'm average, right? It's a pretty average height. I'm like 5'2". Fun fact: this is the only 3D Make It model that's actually life-sized. I have two laptops, one big and one small, because even I may not be big, but I may be small, but we're earning that big money. Why are you standing? Because they don't make chairs my size. Way to rub it in, Akshat, you know? Nice way to rub it in. No, Roxana, don't. This is small make it. Wait till you see teeny make it. Oh no. Oh no, will the next request be teeny? Actually, oh, that would be actually pretty good. And make it, small make it, and teeny make it. Or actually make it, mini make it, and micro make it. That would be a good trio. You know, make it as the main thing. Then mini make it on like the shoulders of it, make it, and micro make it on the shoulder of it, mini make it. Infinite loop smaller makers, precisely, yeah. Well, cool, we are rendering, sweet. I guess we might as well go back and script some more. they're expensive, I don't have them. They cost a lot of money. If I had the money for that, I would buy them. I would be first person to. Reminds me of I have no fingerprints thread. I don't know actually that one. If I do remember, the energy for the gravitational potential energy, by the way, is weird. Because if I do remember correctly, it's U equal to fraction of GMM divided by R, but all of this is negative, if I do remember correctly. Which is curious. And that's because you want the energy to get higher as you go up, but at the same time the rate at which it's going higher as you go up you want to get lower. That's why you divide by R and then put in the negative, which leads to a gravitational potential energy actually being negative. But let me check. Yep. Gravitational potential U is a work done by gravitational force in bringing the masses together. And so this means it's MMR. Or actually, this should be this. There. Do you have a girlfriend? No. What part of me would lead you to believe I'd have one? For some reason that sounded weird. But is it just me or that sounded... I have one. It sounded... I don't know, bad taste. Do you have a boyfriend? I wish. I mean, no, I don't. Do you have a bald friend? No, actually, well, yeah. Well, wait, hold on. What's the line for bald? What's the line for bald actually? You mean like completely bald or bald as in the style of bald? Because when it comes to the style of bald, then yes. When it goes to bald as in just pure bald, then no. Bald full of hair. Well, I have never heard that definition. Do you have a big friend? Yeah, I would say I have a couple. Bald in spirit. Then also yes. Tefta is basically Charles Xavier from the X-Men. And in this case, I mean... Well, yeah, Charles Xavier from the X-Men. Oh, that was so funny, my OBS is disconnected. I didn't mean that as a compliment. Charles Xavier was like a big deal, smart person, activist, philanthropist, so I would say that fits. What was I doing? Oh yeah, right, energy. Yeah, I got sidetracked. That's why it's so convenient rendering animation in the background, you know? You can just talk about random things and pretend like you're walking. Like, okay, let me check. And can I show it on stream? Is it... I would just like, I'm scared. 2013. You never know weird things in 2013, right? Oh, okay, I see, I get it. It's each time there's like a different... That's really good, actually. That's really, really good. How'd you take that photo? It just keeps going, of course it just keeps going. The dedication. Alright. But that's boring. Extraction cooler. Potential gravitational retrieve equation of U is equal to negative GMM divided by R. Mind not doing that? My SOB is disconnecting every 5 seconds. Stream. I have no idea. I have no idea why it just keeps disconnecting. It might be a YouTube problem though. They might not like my VPN. That's their problem. So mass is positive twice. Yeah, because there are two masses. Basically, for each thing I say, I will highlight a different letter. And so gravitational constant is positive, mass is positive, displacement is positive. I have to say twice. Which means if you multiply up these possible positive values. Actually, the conclusion of this subchapter will be mainly the same one we had with energies. Still can't understand it. Still can't understand what exactly had happened. SDC, by the way, welcome. How could that possibly make any sense? Would that be a good example? I think that would be. Oh, Old Kid 2. That's the grooviest song I have. As much as I love the theme for Odd Kid 2, yeah, I know its name precisely because of how groovy it is. I mean, This is the grooviest song. I mean, oof. Try not to jump challenge failed. Ground beneath it, so. And here's where the big. Wait, am I seeing that right? I know if my stats are faking me. Wait, did 5 people just leave? Well, I'm so sorry for. I mean, we can watch this render if y'all would prefer that. It's a good looking light bulb thingamajig. This scene is surprisingly nice though. I love watching stuff render. Yeah, it's fun. It's like watching a paint dry. Except every minute it gets replaced with a different slab of paint. It's almost better than watching paint dry, yeah. Alright. 0. What if... Okay, there's change in energy, not the total, that's true. Huh. Things. Says ground level, said us. You just said us the ground. So, hold on, let me show you what I mean. if you have a ball, right? If you have a ground and you have a ball, then this ball has gravitational potential energy. If I do remember correctly, well, actually I don't have to remember correctly, it will just be as some sort of constant, which is gravitational potential times the mass of the Earth, multiplied by the mass of our ball, like this, with B. And this, if you set it to the ground, if you set the ground as right here, if distance would be the height, then divided by the height, negative. So, am I doing this right? Well, it's the difference in this case. Double check the difference. 320 mechanics with force, yeah. Am I doing this right? More coffee? Would love to. We did double check that yesterday on stream, but on the very end, right when we were finishing up. And I remember it did make sense. So if you have two balls, one up, one down, then the coordinate of this one, no, because the R doesn't make sense. What did I screw up? I screwed up something. Into particles and do not scale the product. I know what I'm trying to say, and I know that is correct, because it's like one of the basic things you learn when working with energies. It's just not clicking in my brain right now. You know, Roxana, actually, thank you for asking this, because something is off. Either in my understanding or in I gotten it wrong. If I gotten it wrong, that would be really odd, because that's the one thing I've actually learned. That's the one thing I remember from school. It's so basic. So if I got it wrong, that would be pretty awful. This equation just isn't clicking for me. Basically, mathematically it makes sense. The higher the distance, the lower this number gets, but because it's negative, the higher the number gets. Okay, so we have this distance. So, alright, let's do it. This will be our core of the Earth, and then this right here will be our earthy distance. This will be the height. Then the energy of this ball will be equal to negative constant times mass of the ball. They will have the same mass, divided by E. And then the gravitational potential of this ball will be negative constant mass HE. And then, because of that, this number is higher. So which means that this number, which means that Cm divided by HE is lower than Cm divided by E. However, when we add a minus to both sides, the switch, because it's negative. Which makes sense. It will basically saying is that this ball has everything tracks. What am I getting so confused about? Everything is correct. It's not helpful. Really, what am I getting so confused about? This is all really basic stuff. I feel like I'm having a stroke, honestly. I feel like I'm having a mathematical stroke. This is all really, like, really basic stuff. To call it high school level math would be an overstatement. But yet, for some reason, it's not clicking in my brain. Mathematical stroke, yeah. Okay, the entire point is... The entire point would be, at least... Oh, my taskbar is broken again. That this is negative. Which means the gravitational potential energy is actually negative. Work is gained from loss of potential energy. Wait, how does this track? Okay, so this from every single thing we've seen so far about the gravitational potential energy confirms what I've written down. I just, for some reason, I can't put it all together. It feels awful. Oh lord, this feels awful. Okay, so yes, but what I'm getting confused about is the value. Once we calculate that, we would get a negative energy. Which would mean that if you... Okay, I found it. I found the thing. Okay, if the ball drops right to the center, then the distance would be 0, which means you would get constant mass divided by 0 negative, which is negative infinity. Basically. Kind of. Good enough. Which means that if the ball drops all the way to the middle, the energy just goes... well... you can get an infinite energy of the ball going with this. I guess that would be mitigated by the fact that it never can actually drop actually to the, you know, it can never get the distance to 0. That makes sense. Actually a pretty interesting thing to mention, you know. My mic been off. Damn it. It just does that sometimes. Okay. My OBS keeps, there's something off with my PC, you know? Just something clearly very off. The point I'm trying to make in the subchapter about gravity is that there's no real thing is up here because this is just an abstraction. However, I feel like we really should mention the fact that as gravitational potential energy goes, as like the ball falls down all the way, the energy would technically, you can get out of it, would technically be infinite. Hi Namunbai, welcome. What are you working on? A video actually about physics, about wacky maths. So basically breaking physics using wacky maths. So doing weird thing with maths and then using it to break physics. Between two particles and scale. Okay, yeah. So R is the distance between them. Yeah. I'm sorry for being so quiet, Munabai, by the way. You've joined a pretty awkward time because I'm just waiting for this animation to render. Wait, 32 frames in, it's already on the ground. Oh yeah, because I did like bounce, didn't I? You know what, let me double check with Wolfram Alpha to make sure that my math is correct in this, just in case. And math in this case would be fraction of a divided by r and limit, well, actually no, math would be easier in this case. A divided by r, and right here we like Limit as R approaches to 0. Except we don't care about the two-sided limit, we care about it going from 0 on the positive down. Do we care about it going on only from one side actually? Or do we care about from both sides? Yeah, limit from the right is infinity, okay. But technically A multiplied by infinity, but no. I know, I should walk you in the video. Okay. We're already on page 7. Wow, we're going like wildfire. And this is still rendering, of course, this. I didn't want this session to be longer, but I only had 1 cup of coffee, so unfortunately it's not. Unfortunately it's not longer. Following your logic, getting infinite, a very large amount of energy is possible if we do get it from black holes. No. That's actually following the point I'm trying to, what would be the right word? Like parody in this case, I would say. The entire point of this video is that you can get nonsense out of physics using math if you forget about abstraction. And the case of a black hole is actually the exact same scenario. So basically, you're using an abstraction of gravity with the equation of negative of U is equal to negative GMM divided by R, using that abstraction with black holes. So, allow me to demonstrate. You have this, right? Negative GMM divided by R. And if you have a black hole, which just has a dot and a ball falling into it, when the ball reaches the black hole, and it will, let's just say, for the sake of the argument that we're correct, that, you know, things when they fall into black hole, they merge with them, it would reach negative GMM divided by 0, right? This is an abstraction, because what you want in this case is you don't want an infinite amount of energy, you want to get out an infinite amount of energy. So you not only want to generate an infinite amount of energy, you want it to be usable. You want to use it for something. But what would more likely happen is, well, gravitational potential energy, as I mentioned, is a bit of a fiction, as in it's an abstraction, so you will only get the gravitational potential right here, and as the ball falls really close to the core, any sort of gravitational potential that you didn't use to bring the ball next to the black hole, any energy that you didn't use to get the ball to the black hole, will just disappear, because it wasn't real energy to begin with. It just stemmed from the fact that this is an abstraction. So basically, you can't get more energy than you started with, right? You can't just create energy out of nothing. So you used a certain amount of energy to get this ball into this point, and that's the maximum amount you can get. So that's the maximum amount you will get, and anything else will just disappear because it was just inaccuracy brought on by the fact that we're using, you know, abstract math. But yeah, I feel like for now, I know it's a short live stream, but at least we got some work done. Yep, I'm gonna go work on another video. And for now, I suppose that'll be it. Thank you everyone so much for watching, and have a great day. Bye.